So let's now summarize the atomic perspective regarding solids, liquids, and gases. So, why are solids incompressible? They're hard to squeeze to a smaller volume. The reason is the particles in the solid, the atoms, are packed already as close together as possible. You further squeeze them in, they're gonna be there's going to be very strong repulsions among the electrons, not just among the electrons and the nuclei as well. Let me add that. Okay, the nuclei, when they get too close together and when the electrons are all crowded together, they start to strongly repel each other, and that opposes further squeezing. Why do solids have fixed shape? And the reason for that is they do not have enough energy to move apart. So movement of particles in the solid are limited to small vibrations about more or less fixed positions. They're still moving, but they're not able to spread out. Okay, they don't have enough energy to spread out. What about liquids? Well, a liquid is something you get after you heat up a solid, right? So liquids have a little bit more energy. Okay, solids eventually turn into liquids when you heat them, so they gain energy, so they're better able to overcome forces that are keeping them together, but it's not enough to allow them to move more or less independently. So they're still not quite free to move independently. Okay, why are liquids incompressible? Just like a solid, the liquid, the atoms and the molecules are really as close as they can be. Okay, so you can't pack them any more closely. How about a gas? A gas is easy to squeeze. You can compress it to a smaller volume. Okay, and the reason for that is, on average, we've seen that there's a lot of empty space between the particles. Okay, whereas why does it fill the entire container? Well, particles have enough energy to overcome attractive forces, and we've seen that they're, for example, in air, they're at least 20 times bigger. The average distance between the air molecules is at least 20 times the size of the molecules themselves. They're very far apart, and so when they're that far apart, the attractive forces are minimal, and they have enough energy to overcome those attractive forces. So they move more or less independently. Vaporization and sublimation, when you're changing from a solid or a liquid to a gas. Okay, solid or liquid changing into a gas, what happens? It's endothermic because by heating the solid and the liquid, you're giving the particles enough energy to overcome attractive forces among them. Okay. Now you might be saying a foam, like the one you lie on, is a solid. Isn't that easily compressible? How do you explain that? What's in a foam? It's actually a lot of air in between. We have very thin strands of solid, like a mesh of solid, but there's a lot of air in between. That's why it's compressible. It's not just a solid. Okay? So now, let's look at these examples right here. For which physical state is the motion of the water molecules most restricted? Ice, liquid water, or steam? Ice in a solid. Next question. What physical state of matter is being described by the phrase, particles are as close to one another as possible and unable to move? They're still moving, okay? So it's not in a solid, they're able to move in more or less fixed positions, small vibrations. So this the problem with this statement is this statement right here, unable to move. Okay. And just as a comment, there are two other physical states of matter that we're not gonna deal very much in this class. And that's the fourth and fifth physical states. Plasma, this is what happens at very high temperatures, like in the stars. Okay, plasma is really just a gas, except that it's so hot that the atoms are ionized. The electrons are able to separate from the nuclei. Okay, in fact, plasma is the most abundant form of matter in the universe. It's in the stars. Okay, And so if you want more information about that, you just do a Google search for plasma. LANL here is Los Alamos National Laboratory.gov. And then the Bose-Einstein condensate, that is what happens at a very low temperature, and you get some weird behavior there due to what's known as uh, quantum uncertainties. Okay, and so you can read more about that. Just do a search on pbs.org. Okay, do a search for Bose-Einstein condensate on pbs.org, and you'll learn more about that.